Good morning, class. We are looking at chapter 2 limits, section 2.2 limits of functions at infinity. So we covered limits of sequences, and we're going to look at limits of functions at infinity. So here's the synopsis of what we have covered, everybody. A sequence is an ordered list of numbers or function f whose domain is the set of natural numbers 1, 2, 3, and goes to infinity. Limit refers to the long-term behavior of a sequence, i.e. what happens to a sub n of a sequence in a long run. The limit of a sub n as n approaches infinity is L. We say that a sub n converges to L, and limit of a sub n as n approaches infinity is infinity or negative infinity or DNE, does not exist. We say the sequence diverges. To find limits, simply plug in the value and observe. You recall some of the theorems. The limit of r to the power of n as n approaches infinity is 0 if r is between -1 and 1, 1 if r is 1, and infinity if r is larger than or equal to 1. The limit of 1 over n to the power of p as n approaches infinity is 0 for p larger than 0. The idea is that when the denominator gets larger and larger, the fraction gets smaller and smaller. A geometric sequence becomes a geometric series when you add up the first n terms, you get a times 1 minus r to the power of n over 1 minus r. When r is between -1 and 1, the limit becomes a over 1 minus r because this goes to 0. B sub n plus 1 is r b sub n, or b sub n equals b sub 0 r to the power of n. By the way, b sub 0 in some text are represented by a. That's the good old geometric sequence and the solution for it. When we add a constant, such as giving medication to patients, the solution gets a little bit more involved. So not only we have that, we add this part. So b sub n is b sub 0 r to the power of n plus c times 1 minus r to the power of n over 1 minus r. And again, b sub 0, remember, it's the same as a. So very straightforward, everybody. 2.2 limits of functions at infinity. And here's the summary definition. Horizontal asymptote, HA for short, of the curve y equals f of x is y equals L, where the limit of f of x when x approaches negative infinity is L, or the limit of f of x when x approaches infinity is L. This is the concept known as the end behavior of a function. This limit is 0. The limit of 1 over x as x approaches infinity is 0. The limit of 1 over x to the power of p as x approaches infinity is 0 when p is larger than 0. We've discussed that with the previous sections, and instead of x, we used n. But this is in general x, a continuous function. So if you look at this function, it's a familiar function. It's an exponential function. Y equals b to the power of x, b is larger than 1, so you have an exponential growth. In this case, when b is between 0 and 1, you have an exponential decay. So in this case, the limit of e to the power of x as x approaches negative infinity becomes 0, or y equals 0. The x-axis becomes the horizontal asymptote. The limit of f of x as x approaches infinity is infinity. The end behavior is in the first quadrant. This one, the limit of e to the power minus x as an example, as x approaches infinity is 0. And the horizontal asymptote, as I mentioned, the x-axis, which has the equation y equal to 0. And of course, the limit of f of x as x approaches minus infinity is infinity. If you look at this function, y equals x cubed, the limit of f of x as x approaches negative infinity is negative infinity, and the limit of f of x as x approaches infinity is infinity. As I mentioned, it is known as the end behavior in algebra. We want to find the limit, and just as we did in previous sections, and you have a rational expression when x is approaching infinity or negative infinity. The technique is to divide by highest degree term in the denominator, in this case x squared. So we make up 3 fractions. Now, I'm going to show you the limit laws, but right from here, you can get to the answer. Because this goes to 0, this goes to 0, this goes to 0, this goes to 0. The answer is 3/5. But the idea of a limit laws, just for practice, you apply the limit to the numerator as well as the denominator. The numerator gives us 3 limits. The denominator also gives you 3. And now, as I mentioned, you can go directly to that because this one, this one, this one, and this one, each one is 0. So the answer is 3/5. And so if you look at the graph, you see the horizontal asymptote y equals 3/5 or 0.6. Also, the limit of the function as x approaches minus infinity is 3/5. Infinite limits at infinity. The notation limit of f of x as x approaches infinity is used to indicate that the values of f of x become large as x become large. Similar meanings are attached to the following symbols. Limit of f of x as x approaches negative infinity is infinity. Limit of f of x as x approaches infinity is negative infinity. Limit of f of x as x approaches minus infinity is minus infinity. The end behavior, that's the concept in algebra. So look at all of these functions. All of them. The limit of f of x as x approaches infinity is infinity. As we go to infinity, the y blows up to infinity as well. But for example, this one, the limit of f of x as x approaches infinity is infinity. The limit of f of x as x approaches negative infinity is negative infinity. So conceptually, I hope everybody is fine with those. So how do we find the limit? Just plug in and observe. For example, if you are interested in the limit of f of x as x approaches and you plug in and you get a number, you're done. You get 0 over some number. The answer is 0 and you're done. You get some number over 0. You have to further investigate. It's either negative or positive infinity. But in calculus, most of the time we end up with indeterminate forms because we end up with 0 over 0, infinity over infinity, or infinity minus infinity. Which means more work. I'm going to say indeterminate forms in short means more work. You have to use your algebraic techniques. For example, if we were to just plug in, we would notice that we get infinity over infinity here. And the more work, because you're dealing with a rational expression, and because t is approaching infinity, the technique is division by highest degree term in the denominator. We're going to simplify each term in the numerator as well as the denominator. Because t is approaching infinity, everything goes to 0. Except this. So you're looking at 0 over 1. 0 over 1 is 0. Same thing for part B. If you plug in, you get infinity over infinity. Please understand. If you plug in, you get infinity over infinity here, you get infinity over infinity here, and the technique, because t is approaching infinity, is to divide by highest degree term in the denominator, namely t. And simplify. So what happens? Infinity plus 2, 0, 5, plus 0. So the numerator is infinity plus 2. That means infinity. The denominator is 5 or 5,000 or 5 billion. Makes no difference. You get infinity. Okay. Infinity times the positive number infinity. Infinity divided by a positive number is infinity. The only thing is, if this was negative, we would get negative. Here's another one. If you plug in you get infinity minus infinity. Because square root, if you were to plug in class, you would say square root of infinity squared plus 1 minus infinity. And I hope you recognize this as infinity. You get infinity minus infinity. What is infinity minus infinity? Indeterminate. Now, what do we mean by indeterminate? I'm going to say, to me, indeterminate means more work. What do I mean by more work? Use your algebraic techniques to figure out what to do. The algebraic technique is to multiply by the conjugate. The conjugate for a minus b is a plus b. The result is a squared minus b squared. So the conjugate for this one is the same expression. Change the negative to positive. So you're going to multiply and divide by it. The reason you have to do that, because this expression is equal to 1 and therefore acceptable. So what happens to the denominator? Absolutely nothing. You just extend this and you have the denominator. Now the numerator, you get a different color. Actually, let me just clean up. So you get this expression squared minus this expression x squared. So the first one comes out of the radical sign. They cancel each other. And now if you plug in infinity, you get 1 over infinity plus infinity, which is 1 over infinity, which is 0. Now, it happened to become 0. But it's important to understand it may not. We plug in e to the power of minus t. That means e to the power of minus infinity is 0. And here's the reason. A to the power of minus m is 1 over a to the power of m. Therefore, e to the power of minus t is 1 over e to the power of t. And if you plug in infinity, 1 over e to the power of infinity is 1 over infinity, and it's 0. So the answer is 12 over 4, or 3. Now, this is not a rational expression. However, it's a fractional format similar to that. And if you plug in, I hope you recognize you get infinity in the numerator over negative infinity, because this is 5, this is e to the power of infinity is infinity. This is 4 minus 3 times e to the power of infinity. So this is negative 3 times infinity. So that is indeterminate. So because t is approaching infinity, you divide by the highest value instead of higher. That's the degree term by highest value, which is e to the power of t in the denominator. So we divide everything by e to the power of t, and we simplify. We get this one. Needless to say, because t is approaching infinity, this goes to 0, this goes to 0, 1 over negative 3 or negative 1/3 is the final answer. In this case, we get infinity minus infinity. If we plug in, we get infinity squared minus infinity. That's infinity minus infinity. And that's indeterminate. Indeterminate. So what's the technique? Factor it. We factor the x out. When we do so, now we can plug in. We get infinity for the first one, and we get infinity minus 1 for the parentheses. The product is still infinity. If you recall in the previous page, infinity minus infinity resulted in 0, and now it resulted in infinity, and in some cases may result in a number somewhere in between. That's why it's indeterminate. That's why you don't know unless you do more. We are looking at a rational expression. X is approaching infinity. You must divide by highest degree term in the denominator. We're going to divide everything by x. Term by term. Now x is approaching infinity. So the numerator is infinity plus 1, the bottom is 0 minus 1. Here's what you want to be very careful. You're dividing by negative. Doesn't matter, negative 1 or negative 10. The result is negative infinity. Okay? So this is the one you want to be careful of. Could somebody read this question for us? Anyone want to read this for us?
Sure. The Pacific halibut fishery has been modeled by the equation b parentheses of t is equal to 8 times 10 to the 7th power over 1 plus 3e to the power of negative 0.71 t, where b parentheses is the biomass, which
This
is,
is B of t. B of t. This is
oh,
a
b of
function.
t.
B of t. Go ahead, please.
Thank you. Is
Thanks.
the biomass the total mass of the of the members of the population in kilograms at the time of t. Part A, what is the limit of b of t?
As t approaches infinity.
That's it.
Perfect. Thank you so much. I appreciate that. Well, we want to take this limit, everybody. So we write the limit of b of t as t approaches infinity is the limit as t approaches infinity of 8 times 10 to the power of 7 over 1 plus 3e to the power of minus 0.71 t. Now, this part goes to 0. Everything else remains. Why is this going to 0? Because a to the power of minus m is 1 over a to the power of m. Therefore, e to the power of negative 0.71 t is 1 over e to the power of positive 0.71 t. And this is 1 over e to the power of 0.71 times infinity, which is 1 over infinity, which makes it 0. Okay, so that's the reason, everybody. I hope everybody is following that. It's extremely important to remember what we have learned in basic algebra. And so, simply put, this is 0. So we get 8 times 10 to the power of 7. That means 8 with 7 zeros kilograms. What is the significance of this limit? What does it mean? In a long run, the Pacific halibut biomass will be 8 times 10 to the power of 7 kilograms, or as I mentioned, 8 with 7 zeros, 80 million kilograms. This is scientific notation. This is a decimal notation or standard form. A tank contains 5,000 liters of pure water. brine that contains 30 grams of salt per liter of brine is being pumped into the tank at a rate of 25 liters per minute. Show that the concentration of salt after T minutes in gallons per liter is V of T equals 30T over 200 plus T. So the first part is for us to show this and basically do this algebra. That's all. So concentration of salt, that means the amount of salt in gallons over the amount of liquid in liters. That's the meaning of this. First, we understand this meaning. So we have 5,000 liters of pure water or liquid to begin with. We are adding 25 liters per minute. And each liter has 30 grams of salt. So 25 liters per minute of brine is added. So after T minutes, we have 20, after T minutes, we have 25 times the T liters of brine added. For example, after 1 minute, 25 liters. After 2 minutes, 25 times 2, 50 liters. After 3 minutes, 25 times 3, 75 liters. That's the concept. Now, according to this, 1 liter of brine contains 30 grams of salt. So basically, you have to multiply this many liters by 30 grams to get the amount of salt after T minutes. 25 T times 30 grams of salt. So that will give us 750 T grams of salt. That would be the numerator. But how much liquid do we have? Well, we have originally 5,000 liters of pure water. And we are adding 25 T liters of brine. So this would be the denominator. So we just proved this should be the answer. And all we have to recognize, there is a common factor of 25 between the top and the bottom. And what you are left with is what was given to us. So this is pure algebra, everybody. Part B, what happens as t approaches infinity, meaning take the limit. As t approaches infinity. you are dealing with a rational expression. T is approaching infinity. You divide by highest degree term in the denominator, namely T. You divide everything by T, everybody. And you simplify. As you can see, when T approaches infinity, this piece goes to 0. We get 30 over 0 plus 1, or 30 grams per liter. Now, what does it mean? How come we get the same amount here? The idea is very simple. You have 5,000 liters of pure water. That's a lot. However, if you add this indefinitely, you add so much that this amount basically becomes nothing. And therefore, in a long run, all the liquid turn into brine for all practical purposes. Again, you still have 5,000 liters of pure water in there, but you have so much brine that it makes no difference whatsoever how much we had in the first place, how much of pure water. So it becomes pure brine for all practical purposes.